Hello everyone. In this video we're going to be solving a radical equation. We have square root of x plus 4 over x equals x minus 2 over square root of x. And we're going to evaluate x squared minus 5x. In some cases we can find this directly. Sometimes we can solve for x and just plug it in. So I'll be presenting three methods, even though the first one or the third one I'm not going to finish completely. And let's start with the third method. Okay, so third method first. So here's my third method. We have, let's make a common denominator, but let me rewrite the original problem first. So this is our equation. Let's go ahead and multiply both sides by square root of x. If you do that, we're going to get, something interesting. Let's go ahead and distribute. Square root of x is going to cancel out on the right-hand side. And the left-hand side is going to give us x plus 4 over square root of x equals x square root of x minus 2. And then basically we can go ahead and make a common denominator here, x square root of x plus 4. And then multiply the square root of x by the right-hand side, like this, distribute. And this gives us x square root of x plus 4 equals x times x, which is x squared minus 2 times the square root of x. And then you can go ahead and square both sides and get rid of some of the radicals and keep doing it until you get something nicer. But this is not going to turn out to be very nice. That's why it's the third method. But I wanted to do it first, get it out of the way. Anyways, so if you do the squaring both sides, you're going to get something like this, which is very messy. And then you can kind of put everything on the same side that doesn't contain a radical as opposed to something that contains radicals. And you're going to get something like this. And then you can square both sides and so on and so forth, right? So that's going to be, yes, super duper messy. And this is probably, and I don't know why I'm cubing that. Square both sides and, you can do it, right? Okay. This is quite complicated or messy. So we don't want to do that. Let's go ahead and take a look at another method, which is going to be our first method. I'm going to do first method next and the second method last. So for my first method, and again, as always, I'm going to rewrite the original problem so you can get to see it. X is positive. Don't forget that, right, at the end. I'm going to go ahead and multiply both sides by x this time. X root x plus 4 equals x squared minus 2 times square root of x. Kind of makes sense, right? Okay, let's go ahead and put the radicals on the same side, obviously, and then I can write it this way. And then square both sides. Okay, this makes sense, right? I mean, we have radicals on the left and non-radicals on the right, so let's make sure we get rid of all the radicals. So if you square x root x, that gives us x squared times x, because square root of x squared is x, right? And x squared is x squared. So this gives us x cubed. In other words, this is also very helpful with some factoring and algebra problems. Square root of x cubed can be written as x root x. Obviously, you want x to be positive in this case. Otherwise, this doesn't work. Okay, so when you square that, I'm going to get x cubed. Plus 2ab, 2 times 2 is 4. X root x times root x is x times x, which is x squared. Plus, if you square 2 times square root of x, you're going to get 4x. I know this kind of looks messy because I didn't take out the square root and there's a purpose. Well, I did it on purpose. Anyway, so this gives us x to the 4th minus 8x squared plus 16. Yeah, it's kind of messy, but at least it's polynomial. Let's put everything on the same side. X to the 4th minus x cubed. And then negative 8 plus negative 4 is negative 12x squared minus 4x plus 16 is equal to 0. Awesome. This is a polynomial equation. Hopefully we have some integer or rational roots. And if we do, obviously they need to be integers because that's monic. The coefficient of x to the 4th is 1. So we're going to be looking at divisors of 16. There's quite a few of them. It's 2 to the 4th power. So we have 5 positive divisors and 5 negative divisors, including 1 and negative 1. And we can test all these out. You can use synthetic division. You can use whatever division. At the end, you're going to find that. But one of the things that's very helpful is always checking for the sum of the coefficients, right? 1 plus 16 is 17. If you subtract from that the negatives, you're going to get 0. So the sum of the coefficients 0 indicates that x equals 1 is a solution. That is a good candidate. So to keep a long story short, this polynomial can be factored into the following. X minus 1 times x minus 4 times x plus 2 squared. Obviously, we do need a double root here because it's quartic, right? And from here, we get the following. Interesting results. X equals 1, as we said earlier, the sum of the coefficients gives us this root automatically. X equals 4 and x equals negative 2. Okay, now let's take a look at each one of these solutions. Examine carefully because they may not always work, right? So what is the original problem? Let's go ahead and rewrite it one more time. The original equation is square root of x plus 4 over x equals x minus 2 over square root of x. And remember at the beginning we said something about x. We said that, hey, x needs to be positive because of square root of x. Therefore, x equals negative 2 is going to be disqualified. It just doesn't work. Too bad. What about the other ones? We can kind of test, right? I mean, we can go ahead and plug it in because squaring both sides introduces extraneous solutions, so on and so forth. If x equal to 1, let's see what happens. 1 plus 4 over 1 and 1 minus 2 over 1. This gives us 1 plus 4, which is 5. This gives us 1 minus 2, which is negative 1. Obviously, they're not equal. Too bad. It just didn't work. So x equals 1 doesn't work either. So we end up with x equals 4. Hopefully that's a solution. Let's go ahead and test it out. Square root of 4 plus 4 over 4 equals 4 minus 2 over square root of 4. This is 2 plus 1, which is 3. This is 4 minus 1, which is 3. They are both equal to 3. We're all good. Awesome. So x equals 4 works, and yay, that is the only solution to this equation. Okay, great. So x equals 4 is valid. It's good to go. Let's go ahead and evaluate x squared minus, what was it, 5x from here. To evaluate that, we're going to replace x with 4. 4 squared minus 5 times 4 is 16 minus 20, and that is negative 4. So the answer is negative 4. X equals 4, but the answer is negative 4. Great. Let's go ahead and take a look at the second method now, and then we're going to finalize our video. Okay. So here's the second method. The second method actually uses a really cool trick, and you could also kind of use that with the first method, but I just didn't want to give it away. I'm going to go ahead and put the radicals on the same side without making a common denominator, of course. So it's going to look like this. And it's kind of hard to see, but if you look at this very carefully, look very hard, you should notice that the right-hand side can be factored by difference of 2 squares. I know it's kind of forceful, but here's the thing. We can think of this as square root of x squared, and we can think of this as 2 over square root of x squared. And guess what? We have them on the left-hand side. Awesome. So we can kind of write this as square root of x plus 2 over square root of x times square root of x minus 2 over square root of x by using difference of 2 squares. These two cancel out, leaving us a 1. So square root of x minus 2 over square root of x equals 1. If you make a common denominator or whatever, you'll get x minus 2 equals square root of x. If you replace square root of x with t, you get t squared minus 2 equals t. T squared minus t minus 2 equals 0. From here, t equals 2 or t equals negative 1. But t is positive, so this doesn't work. T equals 2 indicates x equals 4, and that just means x squared minus 5x is equal to negative 4. And this brings us to the end of this video. Thank you for watching. I hope you enjoyed it. Please let me know. Don't forget to comment, like, and subscribe. I'll see you tomorrow with another video. Until then, be safe. Take care. Don't forget to watch the shorts, and bye-bye.